Okay, so my paper is going to look a little bit different than yours, but it doesn't have a box around here, and so we're just going to go over this. So we're going to read this first thing right here at the top. It says, a way to determine whether two quantities are proportional is to graph them on a coordinate plane. And then if the graph is a straight line and it goes through the origin, then the two quantities are proportional. This is so important right here. Okay, so it needs to meet both of those criteria. So looking at example 1, it says a racquetball player burns 7 calories a minute. Determine whether the number of calories burned is proportional to the number of minutes played by graphing on the coordinate plane. Okay, so they made a table of the calories burned for 0, 1, 2, 3, and 4 minutes. Okay, so at 0 minutes, they burn 0 calories. At 1 minute, they burn 7, 2:14, 3:21, and 4:28. Then they also graphed those ordered pairs right here and put them in a line. So we're trying to decide if this example is proportional or non-proportional. And we're going to write the equation in just a minute. So we're going to say that because it goes through 0, 0, and it goes up in a straight line, the graph is proportional. Okay, so the graph will be proportional. Now, just as an added step, I'd like to start figuring out the equation. So what's happening here? The change here is plus 7, plus 7, plus 7, plus 7. The change on the top is plus 1. So if you remember that, we said K equals, y, the change in y over the change in x. So if I said the change in y is 7 over the change in x, 1, then that's going to be our K. And remember, we also said that y equals mx plus or minus b. So remember that this little thing right here is also K. It's also, unit rate and all those things, but K is the primary thing we're looking for here. So if it's proportional, it goes through 0, 0, so that means there's no b. So I would write this equation as y equals 7x, because it's multiplying by 7, and I'm going to insert this into my equation right here. Okay, so looking at that, we checked out the graph, or the table. We looked at the graph, we made all of our connections right here with the points. We decided it was proportional, and we wrote the equation for it also. Okay, so that being said, it reads right down here. It says the line passes through the origin and is a straight line, so the number of calories burned is proportional to the number of minutes of the racquetball played. For some reason, it's splitting it up different. It's just the way I downloaded. Okay, so look at number 1. Ooh, man, I was drawing on my board. Look at number 1. It says Coach Elkins spends $7 a month plus 10 cents per minute. Determine whether the cost of the month is proportional to the number of minutes by graphing on the coordinate plane. Okay, so looking at this, important information is the $7 a month and 10 cents a minute. So when we start our graph, if we were to graph at 0 minutes, because here's our minutes and here's our cost, at 0 minutes, we're going to start out at $7 because we have a $7 a month plan. At 10 minutes is what they have on the graph. We would say times 10 cents a minute. Okay, so 10 minutes times 0.1, which is 10 cents a minute. It would be $1 if I were thinking money. So we would add $1 to our original $7 a month, which would be $8. So at 10 minutes, we would be at $8. At 20 minutes, we would add one more dollar. So we would be at $9. And 30 minutes, we would add another $1 for that 10 minutes, and we would be at $10. And it's going to keep on going up in that continuous pattern. And you're going to add $1 for every minute, all the way up, okay? So if I were to look at this, I would say this is non-proportional, okay? And it's non-proportional because it does not start right here at 0, 0. not start at 0, 0. So doing that, it's going to make it non-proportional. If I were to write an equation, I would say the starting at 7 is that y-intercept. So you're going to start with plus 7. And then our 10 cents per minute. Okay, so 0.10x, okay, is going to be our slope. So, or our k. That should make sure that's all solved and through the thing. Okay, so looking at the next question. Number 2. Go ahead and read that to yourself for just a second, and then we're going to talk about it individually. Okay. So, looking at that, sorry, I'm trying to take my attendance real quick. Okay, so it says 8 calories per minute of running. Determine whether the number of calories is proportional to the number of minutes. Okay, so the number of calories is proportional to the number of minutes. Okay, so if we started at 0 minutes of running, what would we be? We would be 0 calories, okay? So if we started at 0 minutes of running, we would be at 0 calories. Okay, what about 1 minute? Where would we be? 8 minutes or 8 calories would be burned. At 2 minutes, we would be at 16 calories burned. At 3 minutes, we would be at 24 calories burned. Okay, 4 minutes, you would be at 32, and 5 minutes, you would be at 40, because it's going up by that rate of 8 calories per minute. Okay, so this is linear. It's also proportional because it goes through 0, 0. So we're going to say this is proportional. Let me make sure I label the sides for you, because that's an important. We know this down here is the minutes happening. Okay, and we know this over here is the calories that we're burning. Okay, so this is a proportional statement. If I were to write the equation for this, we're having a change of y over a change in x. Okay, so I'm sorry, I said that wrong. We should have, if I'm going to say that, I'm going to say y over x. So you're going 8 over 1. So that is my rate of change. Okay, and then my equation would be y equals 8x. Okay, last one is number 3. If Stephanie sells 3 necklaces, she earns a profit of $5. If she sells 4 necklaces, her profit is 10. 5 necklaces, 15, and 6 gets her 20. Determine whether your amount of profit is proportional to the number of necklaces. Okay, I'm going to have you draw a chart right here, and I'm going to, okay? And then 3 for 5, 4 for 10, 5 for 15, and okay. To this sheet, if I graph these, I would say start here. 3 would be 5, 4 would be 10, 5 would be 15. Is this proportional? And you would say, no, it's non-proportional, because it does not go through 0, 0, because she has that loss of her cost of her supplies. Okay, so that being said, it's non-proportional, and then we went ahead and graphed it on the other side. I have the other sheet on the back table, so grab that and get started with your work, and you're just going to decide proportional or non-proportional, and you don't have to find the equation, but if you do, that's great. A little chart, a little bit bigger. So I'm going to say necklaces over cost or money, okay? And so it just starts out kind of with 3. So I'm going to kind of skip some space so we can kind of judge that here in a minute. So if I 0, 1, 2, 3, I'm going to start here with 3. And for 3 necklaces, she made a $5 profit. And for 4 necklaces, she made a $10 profit. For 5 necklaces, she made a $15. And then 6 for 20. Okay, so that being said, I just kind of left some open so maybe we could work a little bit backwards. So here's 2 necklaces. What would she make? 1 necklace and 0 necklaces. So we can kind of see if this lines up. Okay, so at 2 necklaces, if we did our change happening, what's our change happening here? Which is 1 plus 1, right? So here it's plus 5, plus 5. So working backwards, we would need to go 5 here, which would be 0. This would be negative 5, and this would be negative 10. Okay, so I just moved the 5 back from happening here. Okay, and so why I wanted to show you this is that we for sure get that 5 as our K, our constant rate of change, but at 0 necklaces, she had a loss of $10 because that's what her materials cost. So our equation would be 5x minus 10 there. Okay, so if we go